Welcome to VGuide TV. In this video, Current Electricity Part 6, I am discussing about EMF, Electromotive Force. Before watching Part 6 video, you should go through our Part 1 to 5 videos. EMF is called Electromotive Force. As a name, it gives force, but it's not a force. It is nothing but it is defined as the potential difference between the terminals of a cell in an open circuit. It is defined as the potential difference between the terminals of cell in an open circuit. It is also called work done by a cell to bring a unit positive charge from one terminal to the other terminal of the cell. So, from this two definition, you understood that EMF is nothing but the work done. Which work done? You need to bring a unit positive charge from one terminal, that means a positive terminal or like a one terminal to the other terminal. So if you want to move a charge from one terminal to another terminal, what is the work required for that? That is termed as EMF. Or it is defined as the potential difference between the terminals of a cell in an open circuit. What is called an open circuit? Open circuit means no current. It means that the current is not flowing through that circuit. Clear? But its SI unit is same like potential difference and it is volt. Now, I need to tell a basic differences between potential difference and EMF. Many of them will get confused about EMF and potential difference. So, the basic difference is EMF is the potential difference when the circuit is open. And potential difference means it is the difference in potential. I wrote this is difference. Difference in potential when the circuit is closed. So in short, when there is no current, we can call as EMF. We can call the potential difference as EMF. But when the circuit is closed, it means when the current flows, we can call it by a name potential difference. Now, EMF does not depend on external resistance. It means it is independent of external resistance. But potential difference depends on external resistance. V equals IR, we know. It depends on the external resistance. EMF is nothing but the cause. Due to that cause, potential difference is nothing but the effect. So that is a basic difference. EMF is the cause and potential difference is the effect. And EMF can be greater than potential difference. A very important point. EMF can be greater than potential difference, but the potential difference is less than the EMF when the current drawn. If the current we are drawing from that cell, potential difference always should be lesser than EMF. So I just gave 4 basic difference between EMF and potential difference. Potential difference when the circuit is open is termed as EMF. Potential difference when the circuit is closed is termed as potential difference. EMF is independent of external resistance, whereas potential difference depends on external resistance. EMF is a cause, but potential difference is the effect. EMF can be greater than potential difference, but potential difference is lesser than EMF. Clear? Now, with EMF of a cell only, you have to remember another term called internal resistance. Internal resistance is nothing but the resistance offered by a cell. It is defined as the opposition offered by a cell to the flow of current through it. through the flow of current through it. When the current flows through a cell, there will be some opposition. That opposition we can term as internal resistance, and it depends on nature of electrolytes and electrodes of the cell. So it's very important. The internal resistance depends upon electrolyte as well as electrodes, and its SI unit is ohm. So what I need to tell, due to that cell, due to the components in the cell, that means due to electrolytes and electrodes, there offers a resistance. That resistance is termed as internal resistance. And I drawn a simple diagram here. This is a cell of EM of E. Small r is the internal resistance representation. It is connected to an external resistance or an external resistor. Let I be the current comes out from the cell. So what should be the current? According to Ohm's law, it is nothing but what is the potential difference, or what's the EMF? E by total resistance is nothing but external resistance plus internal resistance, that is R plus R. If you cross multiply, E equals IR plus IR. IR is V. V plus IR. So if you take this term to the other side, the potential difference I can write it as V equals E minus IR. It's a very, very important formula in current electricity. V equals E minus IR. The potential difference across this point, across the resistor, you can find by V is equal to E minus IR. V equals E minus IR. Or you can even write in another form to find internal resistance, taking IR to the left side, V to the right side. And divide with V, we get E by V minus 1 into capital R. E by V minus 1 into capital R, where E is the EMF of the cell, V is the potential difference, R is the external resistance. So these are the equations to represent internal resistance. But when I told the definition, I told you one thing, the EMF of a cell can be greater than the potential difference I told you. So there are some cases in which you see here V equals E minus IR means we are drawing the current from the circuit. If we are drawing the current from the circuit, V is equal to E minus IR. But if you are providing current to the cell, that means like this, in that case V equals E plus IR. So see the two cases here. We can write here V is equal to E minus IR. We will write when we draw the current from the circuit. But if you give the current, so in those cases we will write V equals E plus IR. So these two equations you have to remember. So in normal case, when we take the current from the circuit, we use the equation V equals E minus IR. V equals E minus IR. V is equal to E minus IR. Now I want to discuss few important graphs. See here, I drawn total 4 graphs here. So these all related to our equation. I drawn V is equal to E minus IR. From that relation only I am drawing the graph. First graph indicates the graph between EMF and external resistance. I told you EMF is independent of external resistance, so we get a straight line. Next graph is V and R. So I told you potential difference depends on external resistance, so we get a straight line, linear graph. V depends on R. Third one is, you see the equation. In this equation, if I increases, what happens to V? It get decreased. So that is the reason the graph will be like this. So what is happening? As I increases, V value is getting decreased. If I equal to 0, V and E are same. Clear? Now, last case. This graph plays a very important role. So this is nothing but we are just writing an equation for E from here. So I can write E is equal to, what will be E? E is equal to V plus IR. Then from here again I'll take V as common, and we know that I is equal to V by R. So if you take V common, it will be 1 plus R by R will come. That is this equation. So I can write V plus IR. V plus IR as V into 1 plus R by R. So your equation becomes V into 1 plus R by R equals E. If R value tends to infinity, this term will become 0 and V will be equal to E. That will happen only when R value becomes infinity. So this graph only, the variation of this, only we draw it like this. So what is the meaning? You see, when E become equal to E, when V become equal to E, it will happen when R value will be infinity. This is the graph. Very, very important thing. Clear? So I gave you total 4 graphs. One with EMF with external resistance. They are independently related. V with a capital R, that is potential difference with R. V and I, according to this relation, as I increases, V decreases. This one also, same relation only, we are writing in another form, another formula or another form we have written. So V into 1 plus R by R equal to E. In this equation, if R tends to infinity, V will be equal to E. Now I want to do a numerical related with this. If the resistance of the circuit is 4 ohm, the current is 1 ampere, and the resistance is increased to 9 ohm, the current reduces to 0.5 ampere. Find EMF and internal resistance. So in the question, they told when the resistance is 4 ohm, the current is 1 ampere, and the resistance become 9 ohm, the current reduces to 0.5. They gave 2 resistances and 2 current. I have taken my standard equation V equals E minus IR. From here I can write I equals E by R plus R. I just arranged all the term. E will go that side. V according to Ohm's law IR. Then I can write the equation I equals E divided by R plus R. We are just substituting these values. That's all. First case, current is 1 is equal to E we don't know. External resistance is 4 plus R. Equation number 1. Second case means 0.5 equals E divided by 9 plus R. So after getting these two equations, you should cancel E and E. Divide these two equations. So I am just doing dividing equation 1 divided by equation 2. So it will be 1 divided by 0.5 equals 9 plus R by 4 plus R. Cross multiply. 4 plus R equal 4.5 plus 0.5 R. R equals 1 ohm. Then after getting R value, substitute R in any of the equation. I substituted R in the first equation. So 1 equals E by 4 plus 1. So E we are getting the answer as 5 volt. Clear? So now you see what I told. In this we learn about the cell, internal resistance and EMF. So now you see main relation you should remember is V equals E minus IR. But remember the possibility V equal E plus IR case also will come when we give the current, that means charging, or you can call the first this E minus IR for a discharging case, and the last E plus IR is for a charging case. Okay. Now internal resistance is nothing but due to nature of electrolytes and nature of electrodes. And in short, we just defined about EMF. It is nothing but, or the nature is nothing but, it is equal to the potential difference when the circuit is open, or it is equal to the work done to bring the unit charge from one terminal to another terminal. Clear? Thank you. If you need more videos, subscribe our channel V Guide TV.